everybody. In this video, we're going to have a look at summation notation. So what is summation notation? It's a shorter way of writing out a series. So a series, Sn, which we have covered for geometric and arithmetic sequences, can be written in terms of summation notation. Summation notation has three parts. So the first part is we put out where we start our summation, or where we begin our summation at the bottom. At the top, we say where do we stop summing until, and then we have some rule which we follow. And depending on that rule, we will then follow the summation. Now, summation notation is denoted with capital sigma, the Greek letter, which is this symbol over here. Let us have a look at some examples to see how it is done. Okay, so here we have a few sums and we have to write it out in summation notation, or if it is in summation notation, we have to expand it. So the first one is 1 plus 1 plus 1. So we're going to start with our summation and we have an index. It can be any letter you want to. Commonly used is I. So we say I is equal to 1, so we're starting at 1. And how many terms do we have? Where would we like to end? We would like to end 1, 2, 3. So 3 terms later, we'd like to end, and the rule is 1. So each time we do, so when I is 1, we're going to write 1, plus when I is 2, we're going to write 1, plus when I is 3, we're going to write 1. So whenever our index is a value, we are just going to write 1. Let us write what's the second one. So we have the I is equal to 1 to 4 of 3. So when I is equal to 1, we're going to just write 3. Plus, when I is equal to 2, we're going to write 3. So it tells us what to write for each one. When I is equal to 3, we're going to write 3. And when I is equal to 3, we're going to write, 4, we're going to write 3. So again, we write 3, 3, 3. Let's do the next one. We have A plus A plus A plus A plus A. So let's write out our summation notation. We're starting at I is equal to 1. How many terms do we have? 1, 2, 3, 4, 5. So we want to end it at 5 terms. When I is equal to 1, we would like A for all of them, I to 1. So we're going to have this is the sum from A is equal from 1 to 5 of A. Now, for these ones over here, the first 3 that we've done, these are independent of I. So no matter what value I takes, we're always going to assign the same number over and over. So this here we call summing a constant. So the pattern doesn't change each time. It's the same number we're summing over and over and over and over again. Let us look at the second one. So here we have 1 plus 2 plus 3 plus until 10. So this one here is not constant. We are summing different numbers for each value of I. And now we have to figure out the rule. So we're starting at I is equal 1 and we're finishing at 10. So we need to figure out what is the rule that will be changing. So this one is quite simple. It's I. So when I is equal to 1, we have 1. When I is equal to 2, we have 2, plus 3, plus 4, plus 5, plus 6. So as we are changing our index, we are summing up 1. Let us have a look what the last one means. So here we have the sum from I is equal to 5 of 1 over I plus 1. So the first term is 1 over 1 plus 1, because that's what I is, 1. The second one is 1 over 2 plus 1. The next one is 1 over 3 plus 1. The next one is 1 over 4 plus 1. And the last one we have to go until I is equal to 5, so 5 plus 1. So there's our values for I. When I is equal to 1, it's 1. When I is equal to 2, it's 2. When I is equal to 3, it's 3. When I is equal to 4, it's 4. When I is equal to 5, it's 5. So we're substituting in 1, 2, 3, 4 in the place of I each time. So this year we can actually write simpler. It's 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. Please watch our other videos to find out more about summation notation and how to apply it to a geometric and arithmetic series. Thank you for watching. Bye.